Hello everyone, my name is Balaji Rao, working as a mathematics lecturer from past 21 years. And today's concept is continuity and differentiability. From this chapter, every year in KCT examination, we'll get 5 questions. 5 questions from a chapter means it's an important chapter. For this chapter, link is there with limits concept. If you already know limits chapter very well, you can understand this very easily. If you don't know the limit concept, it's okay. For first 10 minutes, I'll explain what are the basics you need to understand this concept. We divide, we do this chapter in 4 classes. Today class, we are going to do completely about continuity. If possible, we'll do differentiability problems also, right? So here, you see, this is the definition of continuity at a point. A function f of x is said to be continuous at x equal to a. A function is said to be continuous at x equal to a if this condition holds good. What is this condition? Limit x tends to a, f of x equal to f of a. If this holds good, then we say function is continuous at x equal to a. Here, you need to understand that this must exist. This is limit concept. This must exist and this must be equal to f of a. When these two are equal, then only we say that function is continuous at x equal to a. So here, to understand this chapter further, you must know this concept. Limit extends to a limit concept you must know. So do not worry in case if you don't know this concept, nothing to worry. I am going to explain those things also. For first 10 minutes, what are the things are there in limits chapter, how we will find the limit, what this x approaches to a, what it means, all those things we will discuss first and then we will continue further, right? So first we will see this, see here x approaches to a, how you read this as x approaches to a, and we read it as x tends to a also, x tends to a, or we can read it as x approaches to a. What it means, all those things we learn and then I'll come back to the same slide. Okay. You observe this, how you read this, how you read this. Here, this is like this, x tends to 2, here one symbol is there, minus symbol. How you read this? We read it as x tending to 2 from left. It means x is approaching to 2 from left. On the number line, x is approaching to 2 from left means you observe on the number line, if you mark 2 here, x is approaches to 2 from left. You know, on the number line here left side 1 will be there and here 3 will be there. What this mean? This means that x is approaches to 2 from left. X is approaches to 2 from left means all x values are less than 2, very nearer to 2, but not 2. X approaches to 2 from left means all x values are less than 2, very nearer to 2, but not 2. That means we can take x values like this, 1.9, 1.99, 1.999, 1.9999. What you identified? All these values are less than 2. You can observe that all these values are less than 2. Very nearer to, see, 1.9, 1.9, 1.99, very nearer to 2, but not 2. So from now onwards, whenever you see the symbol, first point, how you read it? You read it as x approaches to 2 from left. X approaches to 2 from left means what? It means that all x values are less than 2, very nearer to 2, but not 2. This is important. This means that x is not 2. X value less than 2, very nearer to 2, but not 2. Keep that in your mind, right? How you read this? We read it as x approaches to 2 from left. You observe this one. How you read this here? How it is? It is like this, x tending to 2 plus is there here. What this is? X approaches to 2 from left. What it is? X approaches to 2 from right. In the same way, this is x approaches to 2 from left. Now, in the same way, x approaches to 2 from right. What it mean? What it mean? It means that all x values are greater than 2, very nearer to 2, but not 2, right? So, x approaches to 2 from right means all x values are greater than 2, very nearer to 2, but not 2. For example, you see here x approaches to 2 from right. You take these values, right? Very nearer to 2, this is not even 2.5, right? X approaches to 2 from right means x values you can take like this 2.01, 2.001, 2.0001, 2.00001. You can observe all these x values. All these x values are greater than 2. All these x values are greater than 2, very nearer to 2, but not 2. So, x approaches to 2 from right means all x values are greater than 2, very nearer to 2, but not 2. Okay. And you see this one, third one. How you read this? How you read this? X approaches to 2. X is tending to 2. What it means? X tends to 2. Here, if symbol is there, suppose the symbol is there, minus symbol is there, it indicates that x is approaching to 2 from left. Plus symbol is there. This indicates that x is approaches to 2 from right. Here no symbol is there. Plus symbol, minus symbol is not there. And what it means? What are the x values? How you read it? X approaches to 2. X is tending to 2, right? It means that all x values are slightly less than 2, or all x values are slightly greater than 2, but not 2. So, what this is? This indicates that x values are slightly less than 2 or slightly greater than 2, but not 2. Okay. So, see here, this is you observe this number line. This part is what? These values are less than 2. These values are x tending to 2 from left, right? These values are greater than 2, approaching to 2. So, these are x approaches to 2 from right. X approaches to 2 means what? X approaches to 2 means, look at this. X approaches to 2 means x values are in the neighborhood of 2. X values are slightly less than 2 or slightly greater than 2, but not 2. That means x values can be like this, or x values can be like this, but x is not equal to 2. So, x is approaches to 2 means we can take x values like this, or we can take x values like this. It just same like example. Suppose take one train. You suppose you are standing at a railway station. You are on the platform. Announcement came like this: train is approaching to the station. Train is approaching to the station. Train is approaching to the station. In case if you don't know the train is coming from which side, then what you will do? You will look this side, right? If the train is coming, okay. Otherwise, we'll look this side. Same way, x approaches to 2 means x value are approaches to 2 from left, or x values are approaches to 2 from right. So, these are the technical terms you need to understand before going to continuity. In limits chapter, you will learn this. However, I am just trying to recall these things quickly. Okay. So, suppose they given like this: x approaches to 1 from left. X approaches to 1 from left. What it mean? Answer. What it mean? It means that all x values are less than 1, very nearer to 1, but not 1. See this symbol. If you saw this symbol, what it indicates? How you read it as? You read it as x approaches to 1 from right. All these things you must know, because while checking continuity, we will check left continuity, we will check right continuity. All those things we will check. Now, that's why you need to know the meaning of these things. X approaches to 1 from left means all x values are less than 1, very nearer to 1, but not 1. X approaches to 1 from right means all x values are greater than 1, very nearer to 1, but not 1. How you read this? How you read this? X approaches to 1. X approaches to 1 means x values are slightly less than 1 or slightly greater than 1, but not 1. I hope you understand this slide, right? So, in every problem, see, suppose while calculating this, you need to calculate like this: limit x tends to 2 f of x. You see this type of things very frequently. Without knowing meaning of this, you started doing the problems, means it's not a good thing. So that's why you need to know these things, what it mean. Okay, right. We'll move to next slide. Okay. You observe here, this is the main thing I am trying to say. Finding the limit of a function is nothing but observing the behavior of the function at a point. You need to catch this point because we'll check continuity of function at a point. For that, you need to know this. Finding a limit of a function. You are finding a limit of a function. It is nothing but you are observing the behavior of the function at a particular point. You observe here, I considered one graph. This is the graph. We'll name this graph as a y equal to f of x. This is the graph y equal to f of x. Okay. Right. At x equal to 1, you observe here, this is the point 1 and this is the point 2. Here at 1, you need to observe the behavior of the function. Suppose while solving the problem, you will see this: limit x approaches to 1 from left f of x. First, try to understand what this means. Limiting position of the function f of x when x approaches to 1 from left. It is simply that when x is very nearer to 1 from left, what is the behavior of the function f of x, where the function f of x is approaching. You observe this graph here. You suppose if I take x value here less than 1, x approaches to 1 from left. Now I take an x value here. The corresponding functional value where you will get, see, corresponding functional value you will get here. This is the corresponding functional value. Suppose if I take x value bit closer to 1, right? Then corresponding functional value where you will get here. Take x value here. So what you observe here, as x is approaches to 1 from left. See what this means? This means that x is approaching to 1 from left. As x is approaches to 1 from left, observe the behavior of the function, how the where the function is approaching. See, these values you will get from here. Try to understand. These values you will get from here. That means where this function is approaching. Function is approaching to 2. From the graph, you can easily understand that if they give like this is left hand limit. Left hand limit at x equal to 1. Limit extends to 1 from left f of x. What it is? As x approaches to 1 from left, function is approaches to what value? Function is approaches to 2. We'll write. I hope you understand. By seeing the graph, you can easily say, as you are seeing this first time, next another 2-3 graphs are there. For that, by seeing the graph, you can answer it easily, right? And you observe here, this one, x is approaches to 1 from right f of x. X is approaches to 1 from right f of x. What it means? When x approaches to 1 from right means what? All x values are greater than 1, very nearer to 1, but not 1, right? So take these things. These are the values which are greater than 1. Corresponding functional values observe. Suppose if you take corresponding functional value, you will get here. Suppose if you take point here, corresponding functional values. So what you observe, when x is approaches to 1 from right, when x is approaches to 1 from right, its function is approaches to 2, right? So if they ask like this, where the function is approaches when x approaches to 1 from right, function is approaches to what? Function is approaches to 2. So what happened in this case? In this case, left hand limit at x equal to 1 is 2, right hand limit at x equal to 1 is also 2. As x approaches to particular value from left and right, function is also approaches to some particular value. What is that some particular value? That some particular value is 2. So in this case, in this graph, left hand limit at x equal to 1, right hand limit at x equal to 1, both are 2, right? That means what I'll write here, left hand limit is same as right hand limit. In this case, what we say? We say that limit x approaches to 1, f of x is 2. See, this you already learned in first PUC, so I don't want to go in depth of this. If I started discussing about this, it may take another half an hour also. I just want to quickly recall what things you need to know. Here, what this mean? What this mean? You observe what this mean? This means that when x is approaches to 1 from left and right, you observe x is approaches to 1 from left and right, function is approaches to 2. Function is approaches to 2, right? So, uh, by seeing the graph, limit x tends to 1, f of x is what means directly we will say it is 2. So, limit exists only when left hand limit exists, right hand limit exists, and they must be same. When left hand limit is equal to right hand limit, they both must exist, and left hand limit equal to right hand limit, then only we say that limit of the function exists, right? You see this another example here. I just want you to answer by seeing this. You see one graph is like this. This is the function y equal to f of x. You suppose this is the function y equal to f of x. This is the graph of y equal to f of x. Okay, this is x axis, this is y axis. You observe the behavior of this function at 2. See, this is 2. At 2, you observe the behavior of the function. That means when x is approaches to 2 from left, you observe when x is approaches to 2 from left, where the function is approaching. From the graph, you need to answer. When x is approaches to 2 from left, where the graph is approaching? Graph is approaching to what value? Graph is approaching to 3. So, in this case, what we say? We say like this, see, limit x approaches to 2 from left, f of x. X approaches to 2 from left, f of x is what? Function is approaches to what? Function is approaches to 3. So, left hand limit of this function at x equal to 2 is 3. Right? You see, as x approaches to 2 from left, function is approaches to 3. So, left hand limit is 3. Similarly, you calculate right hand limit. Right hand limit, limit x approaches to 2 from right, f of x. That means when x values are approaches to 2, see here, when x values are approaches to, observe the behavior of the function. Finding the limit of the function is nothing but observing the behavior of the function. You just observe the behavior of the function when x is approaches to 2 from right, where the function is approaching. Function is approaching to 4, right? So here what happened? Left hand limit at x equal to 2 is 3. Right hand limit at x equal to 2 is 4. So here left hand limit is not equal to right hand limit. When we say limit of the function exists, when left hand limit must exist, right hand limit must exist, and they must be equal, correct? So here left hand limit, I'll write here, left hand limit is not equal to right hand limit. Left hand limit is not equal to right hand limit. In this case, what we say? We say that limit extends to 2 f of x. Limit x approaches to 2 f of x. Yes, what is limit of this function? Observe the graph and answer. Yes, limit of this function does not exist. Why limit of the function does not exist? Because left hand limit is not equal to right hand limit at x equal to 2. I hope you understand this slide, right? Okay. As I said, we are not going to discuss much about limit. I just want to recall all the things quickly. In limits, first year, you learn this concept. Say this is direct method. While finding limit of a function, you have all these things. One is direct method. Direct method. What is direct method? Direct method is also known as direct substitution method. Suppose you see this problem. This problem is like this. Limit x approaches to 1, x plus 2. You need to calculate limit of this function. How you will calculate limit of this function? by direct method. In limits chapter, for any problem, first we try by direct method. Directly we will substitute x value. If it gives the finite number, that is the answer. Otherwise, we'll look for other methods, right? So put x equal to 1. In this, wherever x is there, directly you put 1. 1 plus 2, 1 plus 2 is what? 3. So limit of this function is 3 directly. This is not about left hand limit, right hand limit. Various methods, this you already learned in first phase. I'm just trying to recall quickly. Okay. You see, next one question is like this in direct method. Limit x approaches to 0, x square plus 2 divided by x plus 4. In limits chapter, for any problem, first we try by direct method. You put x equal to 0 in this. Put direct method. If it gives the finite number, that is the limit of the function, right? Put x equal to 0. 0 plus 2. 2 divided by 0 plus 4. 4. That is 2 by 4 is what? 2 by 4 is 1 by 2. So limit of this function is 1 by 2. In the same way, you try here. What is this problem? This problem is limit x approaches to 2, x square minus 4 divided by x minus 2. Okay. In limits chapter, for any problem, we try by direct method. See here, we tried by direct method, it is giving a finite number. So we are saying limit of this function is same. If you try by direct method, in place of x, you write 2. 2 square is what? 4. 4 minus 4, 0. Right? Direct method, 0 divided by 2 minus 2, 0. 0 by 0 is what? 2 by 0 by 0 is a indeterminate form. Right? 0 by 0 is indeterminate form. So when it is indeterminate form, then this other alternate methods will come, right? See here, this is a known as factor method. Factor method, factorization method. You already learned, just I'm trying to recall quickly so that we'll enter into the concept of continuity. Okay. See here, if you try by direct method, you are getting 0 by 0 indeterminate form. That's why factor method means we'll write the factors of the polynomials. Limit x approaches to 2. Here x square minus 4 is there. Now that x square minus 4 can be written as x plus 2 into x minus 2 divided by x minus 2. You see this x minus 2 will get cancelled. Here also x minus 2 is there. Here also x minus 2 is there. That's why we are getting 0 by 0 form, right? You put x equal to 2 in this. In place of x, you write 2. 2 plus 2, right? Now you are getting a finite number, right? 2 plus 2 is 4. So limit of this function is what? Limit of this function is 4. For any problem, first we try by direct method. When we try by direct method, if it is giving indeterminate form, then we look for alternate methods. In that alternate methods, factorization method is one method. And you see this method, rationalization method. Rationalization method is nothing but you rationalize the given function. You look at this in this limit. Question is like this: limit x approaches to 0, root over 1 plus x minus root over 1 minus x divided by x. Okay. You need to find the limit of this function. In limits chapter, for any problem, first we try by direct method. You put x equal to 0 in this. What you will get? 1 minus 1. 1 minus 1 is 0. 0 by 0. Indeterminate form. When indeterminate form is there, then we look for other alternate methods. What are the other alternate methods? One is factorization method, another one is rationalization method. You rationalize the numerator, what you will get here? See, what you will do, numerator, denominator, you multiply with, look at this, I'll write the steps neatly so that you can understand. Divided by x, multiply numerator, denominator with root over 1 plus x plus root over 1 minus x divided by root over 1 plus x plus root over 1 minus x. Okay. So limit x approaches to 0. See, numerator part you observe, this is in the form of a minus b into a plus b. A minus b into a plus b is a square minus b square. So what you will get here? 1 plus x minus of 1 minus x divided by see here, plus 1 minus 1 will get cancelled. Minus of minus is plus. What you will get here? Limit x approaches to 0, x plus x 2x divided by x into root over 1 plus x plus root over 1 minus x. This x will get cancelled. Now you try by direct method. In place of x, you write 0. What you will get? This will become 1. This is also will become 1. 1 plus 1, 2. So what you will get? 2 by 2. 2 by 2 is nothing but 1. So this is rationalization method. Okay. Now we will move to the next slide. See, I think you already know about this L hospital rule, which you learn in first PUC limits topic. In continuity also, we use this very frequently. So that's why I'll explain what is this L hospital rule. Suppose there is a function like this, limit x approaches to f of x divided by g of x. They given while solving the problem something you saw like this, limit x tends to a f of x divided by g of x. When you try to do this by direct method, if it gives indeterminate form like 0 by 0, infinity by infinity, if this results like this, then we can use L hospital rule. Just now in factor method, we did this problem, limit x approaches to 2, x square minus 4 divided by x minus 2. We solved this problem by factor method, we got answer 2, right? Now, you see, this problem is also like this only. This problem is of the form f of x by g of x. When we try by direct method, put x equal to a. Here in this put x equal to 2. 2 square 4. 4 minus 4 0. 2 minus 2 0. 0 by 0. It is giving indeterminate form. When it gives 0 by 0 or infinity by infinity, we can use this L-Hospital rule. This is the shortcut actually to find the limit of a function. Very, very useful shortcut, right? So what I'll do in that case, we'll differentiate numerator, denominator separately. Limit x tends to a, you'll differentiate numerator. Derivative of f of x is what? F dash of x. Derivative of g of x is what? G dash of x. You differentiate numerator, denominator separately, right? After differentiation, you substitute x equal to a. If it gives the finite number, that is the limit of the function. Again, this also results 0 by 0 or infinity by infinity. This also results after first time differentiation. If this results again 0 by 0 or infinity by infinity, then again we'll follow the same procedure. We'll differentiate numerator, denominator separately. Derivative of f dash of x is what? Derivative of f dash of x is f double dash of x. Derivative of g dash of x is what? That is g double dash of x, right? So we'll put x equal to a in this. If it gives the finite number, that is the limit of the function. Otherwise, we'll look for alternate methods, right? If it gives finite number, that is the limit of the function. Again, it gives 0 by 0 or infinity by infinity. This procedure will continue until we'll get the answer. This is known as L-hospital rule. To understand that, you just see this example. When you try by direct method, put x equal to 2 in this, what you will get? 0 by 0 you are getting. When I try by direct method, it is giving like this. So what L-hospital says? L-hospital rule says that you differentiate numerator, you differentiate denominator separately. Okay. Limit x approaches to 2. Differentiate numerator, derivative of x square 2x minus derivative of 4 0. Divide by derivative of x 1, derivative of 2 0. Right? Now you put x equal to 2 in this. Put x equal to 2. Limit x approaches to 2. Put x equal to 2. What you will get? 2 into 2. This is giving a finite number. 2 into 2 is what? 4. So limit x tends to 2. X square minus 4 divided by x minus 2 is what? 4. Right? So in this way, we will find limit of function by using L-hospital rule. And we learn few important formulas which are there in first PUC. I just quickly recall, and then we'll enter into concept of continuity. Okay. See, these are the formulas we have in first PUC. These things also will use in this continuity. That's why I'm doing all these things. What is this formula? Limit x approaches to a, x power n minus a power n divided by x minus a. That is nothing but n into a power n minus 1. This is the formula we have in first year limits. Okay. Another formula, limit x approaches to a, x power m minus a power m divided by x power n minus a power n is m by n into a power m minus n, right? And these are very useful results. Limit x tends to 0, e power x minus 1 divided by x. That is 1, right? In place of x, here ax is there. You see this one? Limit x approaches to 0, e power ax minus 1 divided by x. This answer is A. See, you can do these things with the help of L'Hospital rule also. For example, you see this one. You try this by L'Hospital rule. First, this is of the form f of x by g of x, right? Uh, x equal to 0. Put x equal to 0. E power 0 is what? E power 0 is 1. 1 minus 1. 1 minus 1 is 0. In the denominator also 0, 0 by 0, indeterminate form. So in indeterminate form, we can use L'Hospital rule. What is L'Hospital rule? Differentiate numerator, differentiate denominator separately. So if I continue this further, what you will get? Limit x approaches to 0, differentiate numerator, derivative of e power x is what? Derivative of e power x is e power x minus derivative of 1 is what? Derivative of 1 is 0, e power x minus 0 divided by differentiate denominator separately. Derivative of x is what? Derivative of x is 1. You put x equal to 0 in this, what you will get? E power 0. E power 0 is 1. In case in exam, if you forgot this formula, you can derive this with the help of L'Hospital rule. That's why it is important. You must know L'Hospital rule before doing continuity part. Okay. Similarly, limit x tends to 0, e power ax minus 1 divided by x equal to a. This also you can derive with the help of L'Hospital rule. Look at this formula. In first PUC, this is for 5 marks. Very, very important, right? Limit x tends to 0, sin x by x. In KCET, especially this related problems, continuity questions, they are asking frequently, right? Limit x tends to 0, sin x by x is 1, right? Limit x approaches to 0, sin ax divided by x. Sin ax divided by x is what? It is a. For example, when you are solving problem, something is like this. Limit x tends to 0, sin 3x divided by x is there. Directly you can write the answer. Limit x tends to 0, sin ax by x equal to a. Na? So limit x tends to 0, sin 3x by x equal to 3. Its answer is 3, right? So same like this. This is for sin x by x. Na? This works for tan x by x also. All these things you learn, but these things are needed before starting continuity. That's why we are doing all these things. Limit x tends to 0, tan x by x is 1. Limit x tends to 0, tan x divided by x equal to a. In case if you forgot these things, no need to worry. You can derive all these things with the help of L'Hospital rule, right? Now we'll move to next slide. So finally, after 30 minutes of discussion, we enter into the main concept. What is that? Continuity at a point. See, many students confused to understand this, but this is very easy. I'll discuss all the things graphically so that everyone can understand these things, right? So only thing what I want, you just sit and patiently listen the class. Try to understand what I am trying to say. I'm doing from basic to the next level. So everyone can understand this. Uh, just have patience. Just have patience until this theory is over. Once theory is over, you will feel that previous year KCT questions we will do. You will feel that those problems are very easy, right? Only thing is you need to understand the concept first. Okay. Continuity. Continuity at a point. Continuity at a point. How to check the continuity at a point? Okay. This geometrical meaning is very simple, but mathematical meaning is bit difficult to understand. Here, this is the mathematical definition. A function f of x is said to be continuous at x equal to a. Function is said to be continuous at x equal to a if limit extends to a, f of x equal to f of a. Limit extends to a, f of x equal to f of a. That means to check the continuity of the function at x equal to a, first point, this must exist. Limit x tends to a, f of x. Till now we discussed about limit concept only. This must exist. This must exist, and this must be a finite number. It's not infinite. It must be a finite number. And f of a, this also must exist. First point, this must exist, and second point, this also must exist, and third point, these two must be equal. Then only we say that function is continuous at x equal to a, right? So finding the limit of the function is nothing but, in limit concept we learn, finding the limit of the function is nothing but observing the behavior of the function. Limit extends to a, f of x is what? It is nothing but when x value approaches to a from left and right, f of x also approaches to some particular value, then we say limit of the function exists. Otherwise we say limit of the function does not exist, right? Graphs are also there. With that also we'll understand. This is the mathematical definition of continuity at a point. When we say function is continuous at x equal to 1, suppose you need to check that function is continuous, function f of x is continuous at x equal to 1. How you will check the continuity at x equal to 1? To check the continuity at x equal to 1, first we will calculate this limit x approaches to 1, f of x. Next, we will calculate f of 1. Next, we will check those two are equal or not. Limit extends to 1, f of x equal to f of 1, then we say that function is continuous at x equal to 1, right? Suppose you need to check the, see, one easy thing is, in this complete continuity only one formula is there. This is that formula. When we say function is continuous at x equal to 0, when we say function is continuous at x equal to 0, if this holds good, what is that? Limit x approaches to 0, f of x equal to f of 0. If this holds good, then what we say? We say that function is continuous at x equal to 0. They'll ask, check the continuity at x equal to -1. Check the continuity at x equal to -1. How to check the continuity at x equal to 1? You just calculate limit x approaches to -1, f of x equal to f of -1. If this holds good, then we say that function is continuous at -1, right? So the easiest one, only one formula is there. See, they'll ask, check the continuity at x equal to 10. Limit x tends to 10, f of x equal to f of 10. Then we say function is continuous at x equal to 10. In this continuity, only one formula is there. That is this formula, right? Okay. We'll try to understand this concept through graphs. Instead of geometrically understanding, graphically understanding is important, and it is easy also. Okay. Look at this. This is the function is like this. This is the function. We name it as a y equal to f of x. I am asking you to check the continuity at x equal to 1. Continuity at x equal to 1. See, continuity in this only, its meaning is there, continuous. When we say a graph is continuous, without lifting the pen, if we can draw the graph on its entire domain, then we say function is continuous. I'm asking at 1, this function is continuous or not? That is the question. You observe in behavior of you observe at here, at this point, you observe in this part, any gap is there? Any break is there in this graph? No. So we can easily say that at 1, this function is continuous. At 1, this function is continuous because there is no gap in it. So by seeing the graph, can we say check the continuity? Means we can easily check. You just observe the graph. At this point in its graph, any gap is there, you observe. If any gap is there, then it is not continuous. In this graph, there is no gap. So it is continuous at x equal to 1. You see this second example. This graph is like this. This graph is like this, right? Yes. Now, you check the continuity at 2. Check the continuity at 2. To check the continuity at 2, by seeing the graph, what you can say? At 2, in this graph, there is a gap. So, we say that this function is discontinuous at 2. We say that this function is discontinuous at 2. Actually, now you come to that mathematical meaning. You need to check the continuity at x equal to 2. Now, first you take like this, limit x tends to 2, f of x equal to f of 2. You need to check this. If this holds good, then we say function is continuous at x equal to 2. I'm checking this. Limit concept we learned. As per the limit concept, you observe as x approaches to 2 from left and right, function is approaches to same particular value. No, function is not approaching to same particular value. So here this limit does not exist, right? This limit does not exist. When this does not exist, how you will check these two are equal or not? When this doesn't exist, we cannot check. That's why we say that this is discontinuous. If you can draw the graph of the given function, by seeing the graph you can easily say, by seeing the graph you can easily say there is a gap in its graph at x equal to 2. So this function is discontinuous at x equal to 2, right? You observe this graph. Here it's an open circle. That means this point is not included. You need to check the continuity at x equal to 2. And they defined f of 2 as 4. Here, as x approaches to 2 from left and right, function is also approaches to same particular value or not. See, as x approaches to 2 from left and right, function is approaches to same particular value. Yes, it is approaches to same particular value. That means it is approaching to 3. In this case, what we say, see here, limit, you need to check the continuity at x equal to 2 now. Limit x tends to 2, f of x equal to f of 2. You need to check this. If this holds good, then we say function is continuous at x equal to 2. Observe this graph. You learned in the beginning the concept of the limit. Limit of this exists, limit of this exists, this graph exists or not? See, this exists or doesn't exist. For that, what you do, you just observe as x approaches 2 from left, function is approaches to 3. As x approaches 2 from right, function is approaches to 3. So what we say here, we say that limit x approaches to 2 from left, f of x is what? Is 3, right? As x approaches to 3 from right, sorry, x approaches to 2 from right, f of x. When x approaches to 2 from right, function is approaches to 3. That means what happened? Left hand limit is 3, right hand limit is 3. Here you came to know that this value is 3. Good, very good. This limit exists. Now you need to find this value, f of 2. F of 2 is what? Observe the graph. F of 2. This is open circle. F of 2 is defined as 4. I think you know by seeing the graph how to identify functional values, right? When x equal to 2, what is the function? Function value is 4 here. So here f of 2 is what? F of 2 is 4. What happened? In this particular example, limit x approaches to 2, f of x exists. What is that value? That value is 3. And f of 2 also exists. What is f of 2? F of 2 is defined as 4. This is also defined. This is 3, this is 4. Are these two are equal? They are not equal because this is giving 3 and this is giving 4, right? These two are not equal. When we say function is continuous at x equal to 2, limit x tends to 2, f of x equal to f of 2, then only we say function is continuous at x equal to 2. You can observe here by seeing the graph, you may feel that it is continuous, but actually this is exists, but f of 2 is defined somewhere. Here gap is there. Here gap is there. Here gap is there. This is the open circle. Suppose this is the closed circle. This is not given. Suppose this is the closed circle. Then 100% this graph is continuous, right? Okay, right. You observe from the graph what you say. At 3, this function is continuous or not continuous at 3. This is going like this up to infinity. Right. At the 3, this function is continuous. By seeing the graph, what you see? See, this is going to infinity. This is plus infinity. It is going like this up to infinity. Actually, limit exists, but as x approaches to a particular value from left and right, function is also approaches to same particular value. But f of 3 is what? F of 3 is not defined. In this case, f of 3 is not defined. right? How to check the continuity? How to check the continuity? We'll check like this: now limit x approaches to 3, f of x equal to f of 3. If this holds good, then we say that function is continuous at x equal to 3. But f of 3 is not defined. This not defined. This is not defined. When it is not defined, then how you will check these two are equal? We cannot check. That's why we say that this is discontinuous at x equal to 3, right? And I said now limit extends to a f of x equal to f of a, both must exist and both must be finite. Come to this, in this, what you say, in this at 2, you see this is open circle. This open circle means nothing is there here. Is it is continuous at x equal to 2? No, this is discontinuous at x equal to 2, because in this case also not defined f of 2. Nowhere they mention what is f of 2, right? That's why this graph is also discontinuous at x equal to 2. Okay. See here, this is one important point related to continuity. So I thought of doing PYQs of continuity today. I think it seems to be a bit difficult, but however, first we'll complete the theory part related to continuity today. Next class, we'll do PYQs related to continuity. You see here, continuity is always meaningful when we discuss in its domain. Continuity is always meaningful when we discuss in its domain. Domain means you know how to calculate the domain of function. When we do the examples at the time, I'll discuss this point again, but you need to know that continuity is always meaningful when we discuss in its domain, right? And point functions are always continuous. Suppose this function is there, root over 1 minus x plus root over x minus 1. This is point function. Point function means whose domain contains only one point, right? For this, this domain is only one, x equal to 1 is the only point. Point functions are always continuous. Suppose something is there like this point, one point is there. It is continuous or not continuous means what it means. This domain contains only one point. At one point, one small dot is there. So point functions are always continuous. Okay. You see, these are the points taken from NCERT textbook. You see, what this a real function is said to be continuous if it is continuous at every point in its domain. A function is said to be continuous if it is continuous everywhere in its domain, right? And these are the theorems we have in NCERT class 12th. You already learned these things. We are not going to derive, just we are revising the statements. What statements you learn in continuity? F and G are two real functions which are continuous at C. F is continuous at C, G is also continuous at C. Then F plus G is continuous at C, right? F minus G is continuous at C. Here one point I'll ask, when we say F plus G is continuous at C, when we can say F plus G is continuous at C? Here limit extends to C, F plus G of X equal to f of c. If this holds good, then we say that f plus g is continuous at c. Similarly, if f and g are two continuous functions at c, f into g is also continuous at c, right? F by g also continuous at c, and make sure that g of c is not equal to 0, right? And next, important, every rational function is continuous. Every rational function is continuous. Rational function means what? A function which is in the form of f of x divided by g of x, where f of x is a polynomial, g of x is a polynomial. And one more important point is continuity is always meaningful when we discuss in its domain. Okay. Next, Every polynomial function is continuous. These are all the theorem statements in NCERT textbook. These proofs are there. Every polynomial function is continuous. All polynomial functions are continuous. No need to check if they given any polynomial. Suppose x square plus 1, they given function like this. F of x equal to x square plus 1. It is a polynomial function. Is it is continuous? 100%. No need to check for that. When we say function is continuous, it must be continuous everywhere on its domain, right? So this is a polynomial function. Every polynomial function is continuous. If you draw the graph of this, you can easily check x square plus 1 graph, x square graph. All polynomial functions are continuous, right? Okay. See this one. These are the trigonometric functions. Just now in last slide, we saw that continuity is meaningful when we discuss in its domain. One point you need to know, all trigonometric functions are continuous. All trigonometric functions are continuous. We'll start with the sine function. You see the graph of sine x. You see this graph of sine x function. The graph of sine x function, you all know, the graph of sine x function is like this. It is continuing. Domain of sine x function is what? Domain of sine function is all real numbers. Domain of sine function is all real numbers. You observe the graph. Is there any gap in its graph? There is no gap in its graph. So here it is easy to say that sine x function is continuous. In case f of x equal to sine x is continuous or not. Yes, it is continuous from the from first PUC onwards. You know the graph of sin x function. So by seeing this, you can easily say that it is a continuous function, right? Now, see cos x, graph of cos x. Cos x domain is what? Cos x domain is all real numbers. Graph of cos x will be like this. Graph of cos x will be like this, right? It is continuous or discontinuous. In its graph, any gap is there? There is no gap in its graph. So cos x is clearly continuous. You don't get any doubt in this. Doubt comes only here. See here, tan x. Observe the graph of tan x. You see, this is the graph of tan x. Tan x graph is like this. Any person by seeing this, they'll easily say that it is discontinuous because there is a gap here. There is a gap. Everyone feels that it is discontinuous, but it is not discontinuous. Why? Because what is the statement? Continuity is always meaningful when we discuss in its domain, right? Now you just check that this point. What is this point? Pi by 2. This is the point. This point pi by 2 is there in its domain. What is the domain of tan x? Domain of tan x is all real numbers except odd multiples of pi by 2, right? Because right here tan x, f of x equal to tan x. Tan x can be written as tan x. Tan x can be written as sin x divided by cos x, right? Whenever denominator is 0, this function is not defined. When cos x is 0, here when cos x is 0, when x is odd multiple of pi by 2, like pi by 2, minus pi by 2, 3 pi by 2, minus 3 pi by 2, 5 pi by 2, 7 pi by 2, whenever x is odd multiple of pi by 2, that cos x will become 0. So whenever cos x is 0, this tan x is not defined. Whenever cos x is 0, this tan x is not defined. Clear? So what is the domain when it comes to domain? In the domain of tan x, this pi by 2, 3 pi by 2, 5 pi by 2, these things are not present. Continuity is always meaningful when we discuss in its domain. Suppose, especially, particularly, someone asks, discuss the continuity of the function at pi by 2. Discuss the continuity of the function at pi by 2. We say that at pi by 2, this function is discontinuous. But actually, pi by 2 is not in its domain. You are understanding what I am trying to say here? Tan x is continuous function. Why? Because continuity is always meaningful when we discuss in its domain. You may say, sir, at pi by 2 there is a gap. Pi by 2 there is a gap, but pi by 2 is not in its domain. Continuity is always meaningful when we discuss in its domain. If you understand this, feel happy. Otherwise, you take this point. All trigonometric functions are continuous on its domain. Especially if they ask, in 2023, I think they asked a question about cortex continuity, cortex related thing, right? We'll do that PYQ in next class. You see here, pi by 2. If they specially ask at pi by 2, discuss the continuity of the tan x. At pi by 2, it is discontinuous. Someone asked, what is the continuity of the function tan x? Tan x is continuous, not only tan x. all trigonometric functions are continuous in its domain, right? So this way, here there is a gap, but these points are not in its domain, so we are not discussing these things now. So the theory part, we need to do PYQs also, no? So we'll move forward. Concept of this, what I am trying to say, all trigonometric functions are continuous in its domain. Okay, next. Oh, we luckily we have 5 minutes time. We'll do few problems. We started these problems. You see this question. This is the question given in 2015. Okay. From 2015 to 2024, all the PYQs will do. I thought we can do few problems today, but it is difficult to do problems today. One or two problems we'll cover. What the question they given? See, function f of x given like this. It is a piecewise function. 3x minus 8. Function f of x is 3x minus 8 when x is less than or equal to 5. Okay. This is 2k when if x is greater than 5. Is continuous. They only saying in the question it is continuous. Find k. You find the value of k. As they are saying it is continuous. Continuous means what? It is continuous everywhere in its domain. It is continuous at 5. As it is continuous everywhere in its domain. So this is continuous at 5. So what I'll write? Limit x approaches to 5, f of x equal to f of 5. This holds good because they are saying it is continuous. Okay. Here one problem is there. Uh, See here, this already holds good because they are saying it is continuous. When they say continuous, if this holds good, left hand side, right hand side, both are equal, then we say it is continuous. This holds good means left hand limit exists, right hand limit also exists. From this, what you can write is, see, if you done continuity part in NCERT class 12, you can understand what I am trying to say. Limit extends to 5 from left, f of x equal to limit x approaches to 5 from right, f of x. Because they are saying it is continuous, that means this exists. This exists means left hand limit, right hand limit both exist, they must be equal to f of 5. Here, you see, when x is less than or equal to 5, you choose this function. When x is greater than 5, you choose this function, like that they given. By using these two equations, we can easily solve this problem. See, limit x approaches to 5 from left. X approaches to 5 from left. In the beginning, why we discussed all these things? See, this is the first one we learned in this class. X approaches to 5 from left means it means what? All x values are less than 5. When x value less than 5, which function to choose? This one, 3x minus 8 equal to limit x approaches to 5 from right. X approaches to 5 from right means all x values are greater than 5. When x value greater than 5, what is the function you need to choose? You need to choose 2k. Now, no need of this f of 5 here. Without that, we will get this k value, right? Now, how to solve this? We try by direct method. What is direct method? Where x is there we will substitute 5. Put x equal to 5. What you will get? 3 5s are 15. 15 minus 8 equal to, see, this in this there is nowhere x is there. This is 2k. Suppose while solving problem, something is like this. Limit x tends to 300 is what? In this, x is not there. So its answer is 100 only. You learned this in limits chapter. That's why to do the continuity, concept of limit is important. If possible, whatever you learn in first PUC limit concept, you check once all those things, right? Okay, equal to what? This side you will get. This is 2k, right? 15 minus 8. 15 minus 8 is what? 7, right? 7 equal to 2k. From this, what is k? K equal to 7 by 2. Look at this here, option B, 7 by 2. So, very easy problems they are asking related to continuity. Uh, this class will stop here at this point. In next class, up to 2024, whatever the questions given based on continuity, we'll do all those things in the next class. One more class is required to complete this continuity. This continuity differentiability chapter we'll do in 4 classes. So 2 classes, I think in the next class in 30 minutes, we can complete continuity related all PYQs in KCET. Next class, we'll start differentiability also. So in that way, we'll finish this chapter. I hope you understand this class. Thank you.